Well, hello again. My name is Romance Cheez-It, and today we're going to be talking. This is kind of part two of the grammars and computer science languages series. So today we're going. Well, in the last episode we went over what a BNF was. We went over what a grammar is. We went over the parts of a grammar and how we describe a grammar in computer science languages. Today we're going to go over a derivation. So a derivation is basically, the formal definition is to generate a parse tree from a sentence given a grammar. What we really do is breaking down a sentence into its component parts per a grammar. So we're using the rules of the grammar to break down a sentence to its component parts. This is better shown than actually explained. So the first thing we need to do is establish a grammar. This is our grammar right here. Hopefully you can see it. It's a bit small in this corner, but you can zoom in and take a look at it. And this grammar sets assignment statements like A equals B plus 2. And speak of the devil, that seems to be our example for right now. A equals B plus 2. Perfect. So we're going to start at the very top. The first rule says a program is a group of statements, right? A program is made of statements. So we don't know, we haven't really hit a pattern yet, so we're just going to assume that works, right? So we're going to head down to statements. A statement is either a statement or a statement, semicolon, then a statement, right? So we have two options here. We could say a statement, so statements are either one statement or a statement, then a semicolon, then a statement. We have two options here. We either go from this left one, we either recurse on this left side or on this right side. Since this A equals B plus 2 does not fit this right hand side, we're going to go with this left hand side. So we're going to call this a statement, right? So this in its entirety is a statement. A statement is a var, then equal sign, then an expression. Does that fit that pattern? I would say so. And if you can actually see if you can actually see the screen, you would probably say so too. Because you got your equal sign here, you got your var, and then, or at least you got, your left hand side. We're not going to call it var just yet because we don't know if it actually fits the var pattern. And then you got your expression. So we're going to come down here and we're going to say, okay, a var. We're going to recurse on this right side. So think of like working yourself down a binary tree. You'll see why that is extremely helpful, an extremely helpful visualization in a second. So we're going to go down here. A var is either A or B or C or D. Is this A, B, or C? Is A or B or C or D? Yes, it is. So therefore, we're going to call this a var. It matches pattern var. So since we've hit the terminal, right, and there's no other further derivation, there's no other non-terminal in here, we stop. Now let's go to the right-hand side. So the right-hand side and the other side of the equal sign, we're going to come down here and say, okay, well, we're going to go into expression, and then we're going to say, okay, is it a term plus a term or a term minus a term? Well, this seems to match the term plus term pattern. So this could be a term, then our plus, and then our term. So then we come down here and we say, okay, what is a term? So we ask ourselves, okay, does B match the pattern of term? A term is a var or a const. And if you go and see what a var is, a var could be a B. So therefore, this matches var as well. So if we go down here, we do the same thing. Is this a term? Does this match term? We say, okay, a term could be since it's not a var, it's a const, right? And the const is either 1, 2, 3, or 4. That fits the const pattern, so this becomes a const. Now, I am going to kind of put this, make it a little more visual by putting it into a parse tree. So the way this parse tree works is the exact same way we just went through it. I verbally just kind of walked you through it. So we start out with a program, right? I'm not going to spell program out. Oof, that is awful. We're going to program, right? Start with program, and then we work our way down to statements. And then from statements, we work our way down to, since we already agreed This is not one statement after the other. It's just one regular statement, a single statement. And then from here, we have to do var, as like I said, the pattern var expression expression, as we kind of work our way further down the tree. And then since this is a var, since it fits that pattern, we're just going to leave the a right there. So hopefully this is making a little more sense to you. And then expression, sorry about that. Expression is if you come down here and see what pattern this expression fits, it's the term plus term. So we're going to put term plus another term. And then we found that the part that matches term is var. And the part that matches, on this side is a const. And the const that we have is 2. And the var that we have is b. So hopefully this really helps you understand how we can take a sentence like we did here. This is our sentence, and we'll parse it into a parse tree like this. And this is actually how a lot of languages work. They have a parser which takes a sentence in, parses it into a language like this, and this is actually into a tree like this, and this is called an abstract syntax tree. And that abstract syntax tree has a bunch of nodes that are fed then into a compiler, and the compiler uses that to generate assembly code. Now it could be any type of assembly. You could make one for MIPS, you could make one for NASM, MASM, x64, but usually the binaries depends on whatever type of operating system you're using. But that's basically the basics of how most compilers work. In fact, I'm pretty sure the GCC and G++ compilers work this way. Interpreters are a little bit different. They actually usually take this and go straight into the code, and they compile line by line, so they don't really have to turn into another representation. But this would be called your intermediate representation that a lot of compilers end up having, unless you're C# and Java, and you have like 30 of these different, well, technically 2, but like I said, you have a lot of different intermediate representations. But that's another topic for another day. I just hope you learned and you can grasp what an abstract syntax tree and how to parse sentences. So thanks for watching.